I'm recording. Yes. First of all, let me to just make very fast review of what we did last time. So we started memory management chapter last time, which actually memory is the generic name of all kind of devices that you can store information. So actually, while we are saying memory, we remember RAM, but RAM is a kind of main memory or primary memory. As I told you, memory can be, for example, cache memory inside CPU, or primary memory like RAM, or secondary memory like hard disk. Okay, how we can store data? As you know, we are converting our information to binary while we are storing data, because machine understands from only zeros and ones. So computer converts everything to binary to understand what's going on. Actually, while it is executing in CPU, it should be in binary format. So we showed this one. If you want to just store integer value 10, because of integer, when we are saying to compiler integer, in old operating systems, it is arranging 16 bits, 2 bytes of space. That's why it is made like that. But if we think about today's computers, it is arranging 32 bit of space, which it is 4 bytes. So it is just writing 10 by using 1010, and the rest of them remains as 0 as a number. And of course, sometimes for example, in integers, to store positive and negative integers, we can use sign bits. So if we put 1 here, it means it is a negative integer. If we put 0, it is a positive integer. So because of if our system, if we are going to use I mean signed integer, it is from which it is default value, it is from minus 32,000 something to plus 32,000 something. So it is because of this sign bit. But normally this 16 bytes can store 2 to the power of 16 up to 2 to the power of 16 equivalence of number. I mean, it is something like this. So if we are not going to use this most significant bit as sign bit, and we are going to use it as number, so if all of them are 1, our number will be 65,000 something. And if all of them are 0, our number will be 0. So that's why we are using sign bit, and range is this one. And when it is not signed, I mean the integer, we are not going to use this one as sign bit. We are going to use it as number. So my value that I can store is incremented. I mean, as positive, but this time we can store negative integers. Okay. So also another thing is need for multi-programming, which is how many processes we can store in main memory. It is related to multi-programming. If you are storing 3 processes in main memory, degree of multi-programming is 3. If you can store 5, degree of multi-programming is 5. So we here learned that as much as process I can put to main memory, it will increment my degree of multi-programming, which at the end, it will increment the CPU efficiency or utilization. Like this one, let's say my process size is 4 megabytes. I have 4 megabytes of process and I have 4 megabytes of memory. So CPU utilization is actually 1 minus how many process I have. I mean, so and we are going to take the power of it. If it is 1 process, it is p to the power of 1. If it is 2 process, it is p to the power of 2. Like that. So I can put only 1 process to my memory. In this case, CPU utilization will be 1 minus it is a processor. We will take the power of how many process we have. So if the percentage is, I mean, 70%. So in this case, we will take this one as 0.70. So P is explaining the time that a process does input output. So if a process is just wasting time is 70%, okay? So CPU utilization is 30, okay? What does it mean? I have 1 process, I have I have 1 process, my memory size is just fit to a size of 1 process. So when that process is just tries to make some input output operation, it means CPU will be idle. So if process, if process will not do any input output operation and I have only 1 process, at that time that executing that process, CPU utilization will be 100%. So let me to think about that. This is main memory, okay, and I have a 4K or 4 megabyte of process P1. I have only 1 process, okay. So when this process, if this process is only make CPU bounded operations, I mean, all of them are related to CPU. It is not needing any input output operation. So here, the percentage of input output operation will be 0, okay? Or if it goes to for input output. It goes for input output 10% of the total time, execution time. In this case, it will be 0.1 and the utilization will be 90. Okay, so this is showing me how much time CPU is executing that process, how much time process is doing some input-output operation. Utilization means how much you can use that process. I mean, CPU is used effectively. So this is how we can do it. Okay. So if it is one process, it is P. If it is two process, it will be P square.
P to the power 2.
Okay, I'm going to just. Yes, you are saying something or?
No, I said P to the power 2.
Yes, exactly. Yes. Take a moment. Okay, so we have this time two processes inside the memory. This time we will say 2 to the power P to the power of 2. This is it is a representation of power in computers, also in programming languages. You may see it. This is P to the power of 1 minus P to the power of 2. Okay, if I can put two processes in the main memory, it will be P to the power of 2. Okay, so again, utilization is 70%. It means that in 30%, CPU is executing, okay, of a process. But this is different. Sorry, let me to just make it because in the formula it will be different. So if a process, I mean, I have two processes, but each of them have 70% of input output. So in this case, what does it mean? Because of I have more processes, while one of them is go for input output, I can just execute the other. So it will increment the utilization. So this time I have two processes. I took P to the power of 2. So normally I am taking, if utilization is 0.70%, I will take 0.7. So I will take the square of 0.7. It will be 0.49. Okay, so this time 1 minus 0.49, it will be 0.51. So in previous one, I have one process can fit in main memory, and utilization was 30%, but here it is incremented to 51%. So we can say that if number of processes increments, the utilization increments. Okay. So we know that our aim is to fit more processes, or we work with more processes in operating system. So to just save all of them, not save, to put all of them in operating system, it needs some management, because even it is more processes, each of them have more operations, so it will be more confused. So there are some mechanisms or some solutions to they applied to solve this problem. One of them is fixed partitioning. It was the earliest and the simplest technique that we can load more than one process into the main memory. Okay, the aim is actually we put more than one process, and also each process should know where its border is, where is the border of that process. Okay, it should know. That means when we just put all of the processes, their data will not be mixed to other one. So that's why we are making partitioning. We are arranging a space for each process. So fixed partitioning means in the beginning, it is saying, or it can make different sizes of partitions, but before processes loading to the RAM or main memory, we are arranging a some fixed partitions. So what does it mean? When we arrange fixed partitions, for example, here 3 megabytes, 1 megabyte of space is empty because it is arranged 4 megabytes of space. So someone is writing. Please connect me, Paul. What? You are connected, Paul. You can see? I can see you. Paul, can you hear me?
Yes, I can hear you, Hocam.
No, I'm talking to Paul because he sent me a message that just connect me, but he's connected. Okay, 1 second. Can you text to him from, I think it should see us. He's just trying to connect, I think. Okay. Paul, can you hear us?
Yes, I can hear you, Hocam.
Okay.
Paul is dead.
Abdullah, I am talking to Paul because anyway, I think.
Hello, sir.
Hello.
Hello, sir. Paul, I'm hearing you now.
Yes. Okay, Paul.
I just joined in. I've tried to join since it's disturbing me. This thing was not connecting. So I just enter now. Yes,
okay.
Sir. I can hear Paul. Your voice. Yes, sir.
Okay,
yes, sir.
Paul. Okay, I am also recording the lecture.
So
you
lecture,
can,
yes, sir.
You can just reach the previous. I mean, just we were making lecture since 20 minutes. So
okay,
the
sir.
previous one you can just check from the video.
Okay, sir. Okay, sir. Okay, sir.
Okay. So in the fixed partitioning, we have a fixed partition size arranged in the beginning, and it doesn't matter how much. It doesn't matter how much. That's most probably because of his. Okay. Because of it doesn't matter how much what is the size of processes, It is just arranging a fixed partition. In the example, if the processes are 3 megabytes for each, in this case, there is 1 megabyte of space for each of them. So these are actually wasted parts because of the partition. We can't put any other thing here. So and also contiguous memory allocation, they are calling. It means we are storing one after the other, and we can't divide some process to just put them in another place. It means contiguous. Okay. Just as an information, operating system is always in the first partition. But here you have to remember that partition size can be different. Okay, just they are allocated in the beginning and they are not changing. But here, these are, as I told you, are internal fragmentation. The internal fragmentation means inside the processes, partitions that they are running, they have some space. If there are some space, it is called internal fragmentation. But the total unused space, which it can be something like that. There may be some other spaces that in the memory that it is not created a partition, and also, or maybe processes cannot fit to there, and also with the other unused spaces, it is called external fragmentation. So where I can draw it, let me to show you. Think about that. This is my main memory, and for example, this is one partition, this is other partition. Let's say all the partitions, all partitions size why I'm not writing, I don't know. Let's say 3 megabytes. This is each of them, okay? This one is 3, this one is 3. All of them are 3 megabytes, let's say. And we have some processes. We have some processes. Let's say this is P1. This is P2. And this is P3. At the sizes, this one is, let's say inside just size, this is 4 megabytes. This is 2 megabytes. And this is 1 megabyte. Okay. So here, because of partition sizes are 3 megabytes, P1 cannot be fit to any of this partition. Process 2 can fit one of them. Okay. process 3 can be fit one of them. But here, because of each partition is 3 megabyte, 1 megabyte of space here, 2 megabyte of spaces are here. Okay, and think about also, for example, there are some other spaces that filled by other processes. So external fragmentation is actually a kind of total memory that it is not filled by any process. Internal, you can think about only one partition. Okay, internal is about the partition. External is about all memory. So that is the difference. So okay. Okay, because of the external fragmentation, actually, when we check the unused space of the memory, totally we can see that 4 megabyte of space, but I can't fit this one because partition sizes are not enough. And also we don't have any available partition. So that's why, because of this reason, I can't fit process 5. Okay, cons of fixed partitioning is internal fragmentation. I told you. External fragmentation. So the external fragmentation is total unused space of various partitions. Okay. So so it can be some, for example, partition like this, that there is no job is executing process, but it is still empty. So all of them are actually shows my total size of external fragmentation. Okay, so internal fragmentation, it is inside of the partition. External fragmentation, whole memory. So that is the difference. So the other one limitation on the size of the process, this part, I mean, I think. No, yes, it is this part. Actually, this one is fits both of them. If my partition is, if my process size is bigger than, larger than the partition size, I can't put it inside. And degree of multiprogramming is less because if we can arrange any other mechanism that I can put more tasks inside or more processes in the memory, it will increment my degree of multiprogramming. So if I can put, instead of 4 processes, if I can put 5 processes, degree of multiprogramming will be increment and CPU utilization will increment. So these are the disadvantages. That's why we just try dynamic partitioning. Here the difference is we are not just arranging a partition size, fixed partition size. We are creating partitions according to the size of the process. So if my process size is 5 megabyte, I will create a partition 5 megabyte. If it is 2, I will create a partition 2 megabytes. So, and it is declared at the time of process loading, not initially declared. So here we don't have any internal fragmentation. In dynamic partitioning, we don't have any internal fragmentation. So we know how we did it. The advantage, one of them, is no internal fragmentation over fixed partitioning. The other one, no limitation on the size of the process. So we can say here that my process size is 10 megabytes. If it is not bigger than, process size is not bigger than the memory size, I can put it, I mean, empty available memory. If available memory is 10 and process size is 10 or less than 10, I can fit it. Okay, but in fixed partition, it will not possible always, because it is checking the partition size first. So degree of multiprogramming is dynamic because of we are just not, we are using that, we don't have any internal fragmentation. That's why. And the external fragmentation, yes, in the disadvantages of dynamic partitioning, one of them is external fragmentation. So why? Because while we put some process to the memory, and when their tasks are finished, the partitions remains there, as for example 1 megabyte of free space or 2 megabytes of free space, like that. So this causes external fragmentation because there is no processes there anymore, and if there will be any other process come for to need execute and load to memory, this time it is not I mean 100% sure that they can fit to that size. For example, if it is 2 megabytes, let me to draw. Think about here, I have process 1, I have process 2, process 3, process 4. Let's say this process is waiting for execution. Let's say process 2 is finished execution, okay, and also process 3 finished execution. Let's say they have available 2 megabytes in this case, because of they released available 2 megabytes or 3 megabytes of space in the memory. But this size, let's say I have one process with 4 megabytes. Let's say this one is process 5. Process 5. Okay, it wants to just execute. My available spaces are 5 megabytes, so it is more than we need. But because of these are created partitions, I can't put them here. Okay, but actually I did something wrong here. If they are one after the other, it will be possible. So let's say in this case it is possible. Okay, in this case, because it is one after the other, 5 megabytes of space will be available. But let's say okay, let's say okay, let's say this time P1 and P3 is executed. Okay, and let's say P1 is 2 megabytes again, and P3 is 3 megabytes. And we have P5. Let's say this is again 4 megabytes. Now I can put, because of these are released and they are empty, here these parts are empty, and totally 5 megabytes of empty space. I can't put them because of here I have 2, here I have 3. They should be one after the other. So this is disadvantage of dynamic partitioning, external fragmentation. Okay, we don't have internal fragmentation, but we have external fragmentation, and it is sometimes just not allowing the processes to put into memory, although I mean in spite of they have enough empty spaces. Okay. The other disadvantage is complex memory allocation, because of we are creating partition for each new process, and then we are deallocating. We have to remember the space that they left. All these things are very complicated, and it will actually decrease the efficiency of the system. So one of the disadvantages is this. So what we can do, compaction. Compaction means we can we can just put one side empty spaces, the other side the processes. So it will be more practical in this case. So as you see, empty spaces are in one side, the other spaces that have processes in another side. Of course, operating system is always just in the first part of the memory. Okay, it is a kind of process, operating system, that we should never stop it. It is like our heart. While our heart is stopped, we don't need any other organs and other things. So it is actually operating system should work to just manage all this system. That's why they are putting it in the beginning. So this time the free partitions will be just put one after the other contiguously, and the processes that are executing or waiting the CPU are in other parts, okay, like this. And this technique is called defragmentation, okay. Actually, there is system is just working with this to do it, because think about that, always there are some other processes are coming, some processes are finished execution, and there is the system is trying always to just make them like that, okay, to separate free and the processes. Let me to just draw. Let's say this is memory, and we have processes, process 1, or let's say these are unallocated places, the upper sides, process 1, process 2, process 3, okay, and let's say this part are free. Think about that, process 1 is finished execution, okay, this one finished execution, so this is free. So what should happen, this process should be go to the beginning of this one, okay, and this one or something like that, okay, this should be moved from this part to this part to make all this process, all these empty spaces contiguous and running processes contiguous. But while this one is trying to move at that side, processor should wait for this one. I mean, if it is in this turn, or processor cannot execute this one at that time, which it is, it means it is unavailable. It is making a kind of memory operation. It is unavailable. So of course, this will decrement the degree of the multi-programming and efficiency. So all these things have some advantages and disadvantages. So let me to continue. So I explained what is the problem with compaction, and I explained to you how we can use it. Let me to give a 5 minutes break and continue after the break, because I think the time is up. It will stop the meeting.